feature selection for the data preparation. In feature selection, we have seen different applications where the number of potential features are very lesser than that of the total number of features. So we have to decide a set of features or some of the features. Those are discriminative features. Discriminative features can be beneficial in terms of to reduce the cost of dimensionality, to reduce the feature measurement cost, to reduce the computational burden. For example, we have D features, then the task is to compute m number of features. Those are useful or maybe the beneficial in terms of accuracy and guaranteed the beneficial in terms of complexity, in terms of computational complexity, in terms of computational burden. A Pareto theorem. According to this theorem, in any of the applications, out of 100%, there are just 20% features that are most distinguished or most useful. It also called 80-20 principle, law of vital few, principle of factory sparsity, but the abstract is the 20% features can have the information of 80% of the information. So for feature selection, we have different approaches. One can be the feature selection, the other can be the feature reduction, and above all both of these, we have to extract the features. Feature extraction. Given D features, let's say we call it Y, we are going to compute the m number of features, we call it X, by the combination of previously available features. It can be a linear combination or non-linear combination. In linear combination, we will just multiply with a matrix T, and in terms of non-linearity, we will apply a function on the available features to get the new set of features, and those features will be used for the further processing. Its examples can be PCA or the supervised one, that can be LDA or MDA approaches. The criteria for this feature selection is to increase or to optimize the accuracy or the simplification in the complexity, in terms of time complexity, in terms of computational complexity. The next one was feature selection. Here we are going to decide a set of m features from D available features. Those are useful, at least equivalent useful, and beneficial in terms of at least in terms of time, or maybe in terms of accuracy as well. So one of the approaches is to use the exhaustive search, all possible combinations. Let's say we have 50 features and we are going to decide 10 best features. Then this will cost around 10 billion possible feature subsets, and 10 billion feature subsets means we have to evaluate 10 billion feature subsets, which is practically impossible for a significant amount of data set. So another approach is to apply heuristics. Let's say see the heuristic approaches. Basically there are two approaches, those are commonly being used. One is sequential forward search, the second one is sequential backward search. Forward means increasing order search and decreasing order search. Let's see one by one each. The sequential forward search starts with 0 features and adds the features until unless we got the significant features. For example, we start with feature 0, we have no feature, and then we add a feature that is best individual feature. For example, we have n number of features and applied different algorithms to compute the accuracy of independent feature, and then we add the best feature one by one until unless we got the best combination of features, or we got the maximum amount of feature we are going to use. But here we have a disadvantage. For example, let's assume a feature I is good individually, but it is worst with the feature J, and if we select I, then we don't have option to reject this I. We can select J or reject, but we can't reject this I1. Let's say we can say feature A, B, C, D, E. Okay, let's assume we selected A as a good feature, as the best feature, and then we selected B, and in combination of A, B, this pair is also a good pair. But with the triplet C, A, B and C, it is not the good one. And if we reject the A, then B, C can be more beneficial. But according to this algorithm, we can't select B and C without A in this criteria. So that is the disadvantage of sequential forward search. But this problem can be solved with the sequential backward search. In this, we start with the all set of features and remove the worst feature one by one, iteratively. But here we have another issue. Let's assume, as per the previous example, we have let's say A, B, C, D and E features, and first we have selected all 5 features, and then after rejection of E, the feature set A, B, C and D is the best feature set. But after rejection of D, it is the worst. But now we can reject D or select D, but we can't select again the feature E. That is the disadvantage in this sequential backward search. These both searching algorithms have some disadvantages and some advantages, but the main disadvantage is once a feature is rejected in sequential backward search, it can't be again selected.